You've seen it in the movies, right? The dream of having your own personal AI, like a Jarvis, running right there in your house. Totally private, completely under your control. Well, that dream, it's actually getting really close to reality for a lot of us. But what does it really take to get a powerful AI model running on your own machine? Is this just a game for people with deep pockets, or is it something you could actually build yourself? Let's dive in and find out.
And this right here, this is the kind of passion you see all over the internet from people who are deep in this stuff. This user on Hacker News, Joseph Cube, dropped a ton of money on a Mac with a wild 256 gigabytes of RAM. Now, why would they do that? Simple. To run absolutely massive AI models with their full context, basically their entire memory intact. For them, this isn't just a cool hobby, it's a total game changer.
And that passion, it's really fueling a whole movement. It's all built around this one big idea, the dream of a truly local AI. And we're not just talking about some simple little chatbot. No, the goal is way, way bigger.
People are building these always-on AI agents that can do things like manage their smart home, help them write code, or organize their personal data, all without ever sending a single byte of information to a big tech company's server. This push for privacy and control has gotten so intense, it's actually sparked a run on hardware, like the new M4 Mac Minis. People are snatching them up to be the dedicated, low-power brain for their home AI.
Okay, so you want to build one. Right away, you're going to hit a major fork in the road, and it's a classic showdown. The sleek, integrated world of Apple versus the wild, customizable world of the PC. And believe me, they have very different ways of getting the job done. So on one side, you've got the memory giant, which is really Apple's thing right now. Thanks to their unified memory, you can get a machine with a truly colossal amount of RAM. We're talking 256, even 512 gigabytes that the AI can use directly. This lets you load just ridiculously huge models. But on the other side, you've got the speed demon, the custom PC rig, usually stuffed with powerful NVIDIA GPUs. With the PC, it's all about raw, blistering processing power and that dedicated, super fast video memory, or VRAM.
And yeah, the heart and soul of that PC approach is a beast of a graphics card, just like this one. For AI, the number that matters most isn't the clock speed or anything like that. It's the amount of dedicated video memory, the VRAM. That one spec, it's the key to pretty much everything.
Okay, so I keep saying VRAM, but what does that actually mean? And you hear other words thrown around like quantization. You know what? To really get why the hardware choice matters so much, we've got to pull back the curtain on some of this jargon. Don't worry, it's not as complicated as it sounds. All right, let's make VRAM super simple. Imagine your computer's VRAM is the size of the workbench in your garage, and the AI model you want to run, that's your project. If you've got a massive workbench, you can lay out all the parts for a really complex project all at once. But if your table is tiny, you're constantly running back and forth to the storage closet, which is like your computer's main, slower RAM, to grab parts. And that process is just painfully slow. So what if your workbench, your VRAM, is a fixed size, but you want to work on a bigger project? Well, you use a clever trick called quantization. It's basically a compression technique, but for AI models. Think of it like taking a huge, high-resolution photo and saving it as a much smaller JPEG. Yeah, you might lose a tiny, almost unnoticeable bit of quality, but now it actually fits. This is the secret sauce that lets people run these giant models on regular gaming GPUs. So what does all this mean in the real world? Well, take a look at this table. It gives you a pretty good idea of what you can realistically run on a popular 24 gigabyte GPU. You can see that smaller models, the ones with about 13 billion parameters, and you can think of parameters as like the AI's neurons, they fit no problem once they're quantized. A 34 billion parameter model, okay, that's a tight squeeze. But a monster 70 billion parameter model, no, it's just too big for this workbench. And that brings us to the other big trade-off, speed. This chart here shows the generation speed in what's called tokens per second. A token is basically a word or part of a word. A smaller 8 billion parameter model is blazing fast, spitting out almost 100 tokens every second. But look what happens when you jump up to a 32 billion parameter model. The speed just plummets. So here's the takeaway. A bigger model is often a smarter model, but it is always a slower model. So that raises a pretty obvious question, right? Why would anyone want these huge, slow models? Why not just stick with the small, fast ones? Well, it's because the goal for so many people isn't just to build a better chatbot, it's to build an agent. And that, right there, is the million-dollar question.
What really is the difference between a simple chatbot and a true AI agent?
It's pretty simple when you boil it down. A chatbot talks. An agent acts. It can actually do things on your computer. It can run commands in the terminal, it can organize your files, it can browse the web for you, and it can connect to other apps to get complex, multi-step jobs done, all by itself. This is a huge leap in what an AI can do, and it requires a much, much smarter model to pull it off. And getting one of these up and running isn't as simple as just downloading a file. The process usually involves grabbing a powerful base model, like this 72 billion parameter Qwen 2.5. Then you have to create a custom file to give it a new set of instructions, a new personality. You tell it something like, use tools directly without asking for confirmation. And with just that one little change, you turn a conversational AI into a decisive agent that takes action. Okay, but all this power, this freedom from the cloud, it's not exactly free, is it? So let's get down to brass tacks. What is this actually going to cost you? The starting line is actually surprisingly affordable. Like we mentioned, people are loving these M4 Mac Minis, and you can often find them on sale for around $549. For that price, you get a super efficient, quiet little box that can just sit in a corner and be the 24/7 brain for your own private AI. But if you want to run the really big models and you want them to perform those complex agentic tasks at top speed, well, the cost goes through the roof. This is a real-world build from a Reddit user, and it clocks in at over $9,000. We're talking a high-end Threadripper CPU for insane multitasking, and not one, but two top-of-the-line RTX 4090 GPUs. That's the speed demon approach, taken to its absolute limit. But here's the thing. Whether you're spending $500 or $9,000, the price of the hardware, that's not the biggest hurdle. There is a much, much more important challenge here that honestly a lot of people just forget about when they build these things. And this right here, this is it. This slide shows a massive security gap. I mean, think about it. If you give an AI agent the power to run any command it wants on your computer, what's stopping it from, I don't know, accidentally deleting your entire hard drive? Or finding your saved passwords and posting them online? This table shows you the difference between a raw, unprotected agent and one that's properly managed. With the right setup, your passwords are encrypted, not just sitting in a text file. The AI is put in a sandbox so it can't mess with your main system. And critically, you have a kill switch. This isn't just a nice feature, it's absolutely essential. So after all that, what's the bottom line here? First, the dream of a private, powerful AI assistant, it's not sci-fi anymore. It's really here. Second, the hardware choice boils down to a fundamental trade-off. Do you want the Mac for its massive memory and simplicity, or a PC for its raw speed and endless customization? Third, you gotta remember the catch. Bigger models are more capable, but they're always slower. And maybe the most important point is that building a system that's not just powerful but also secure is the real challenge. There's no single best computer for this. It all comes down to what you want to achieve. Which really just leaves us with one final thought. The tools to build a truly personal, private, and powerful AI are now available to us. We have total control. So the only question left is, what are you going to build with it?